Weather on the Internet. This is a new series I'm going to start here. Take a look at different internet weather websites and show you how to use them. And you hear this sound library. This sound bit thing here, I bought this back in 1998 from a studio called Aurea, and I used this in Artist Storm Chasing. You probably recognize that if you have that video. So I'll probably throw a little of these random ones on as we do these presentations. I'm going to talk about some weather websites. I'm going to introduce weather.cod.edu. So with this series, I'm going to remove the focus on Texas weather and talk about some sites that might help you in other parts of the country. If you go to weather.cod.edu, you'll have a couple of options here: analysis data, satellite and radar, numerical products, and so on. So you'll want to go to one of these menus. So we'll start with analysis products, and this refers to actual observed conditions, instruments and readings, ASOS observations at the surface, not computer models or forecasts or anything like that. So this is a good starting point to understanding what's happening with the weather. I'm going to click on Surface Main here, and we can click on a particular region of the US. We'll take the Midwest, for example. And this gives us surface plots. So at the very top left of each station plot, surface plot, we have temperature, and at the bottom left we have dew point. And these little flags here, they extend into the winds. So the winds are coming from the south-southwest here at the station and blowing to the north-northeast. So we would call this a south-southwest wind. This chart also gives us streamlines, which are these blue dotted lines, and we also have isobars, which are lines of equal pressure. So out here we have low pressure, and out to the right side we have high pressure. How do I know that without actually finding a low pressure or high pressure mark? You use that concept where winds blow counterclockwise around lows and clockwise around highs. So since the winds are blowing north or south to north, I know that there's high pressure out to the east. So what else do we have here? We have Printable Map set. I guess you can send that to your printer. We have raw METARs, which are the actual observations from the different ASOS sites, and you can look at that. And for example, this is Oklahoma, this is Bartlesville right here, and this is coded data. So I'm not going to go into much detail, but this basically shows the winds are out of 170, which is the south, at 8 knots. The winds are variable, and conditions, visibility and sky condition are good, and the temperature is 30 degrees Celsius. So that's about 86 degrees Fahrenheit. Let's see, we got high resolution US raw plots. I guess that's a very large graphic you can send to wide format printers, that kind of thing, or maybe clip that and use it in products. So we got a couple products here. These are derived products. This is like doing a mathematical analysis on the observed data, not using model data. So moisture convergence is going to give us a map like that, and I don't know if I can zoom in on that or not, but this is going to show us where winds are coming together combined with good moisture, and that's usually showing us where we're going to have thunderstorms and showers developing. This is not a cookie cutter catch-all type product, but it gives us a rough idea of where conditions are favorable for development of thunderstorms and showers. Pressure falls, this can give us a good idea where winds aloft are removing mass from the column of air. When that happens, we get surface pressure falls. So this can help us to a certain extent track upper level disturbances, and it will also show us where there's good surface heating and where lows are approaching. Theta E gives us an idea where the thermodynamics are favorable for severe weather. Not quite in the same way as moisture convergence, but this is more a measure of the fuel. So basically, the higher the theta E, the more unstable things are given the same upper level conditions, and the more severe or the more stronger the storms will be. So you might think there's a bunch of severe weather down to the south. That's not exactly the case, because the upper level conditions warm, and that kind of offsets that potential for the fuel to give us good storms. Then we got the basic temperature and sea level pressure, so this just gives us dashed red lines for isotherms and black lines for the isobars. This is showing us a deep low across the central U.S., Canadian high up in Alberta, that's probably moving southeastward. Then we've got our upper level maps. I'm not going to go into too much detail on this because we'll be here all day, but a couple of key maps is the upper level main map. We can click on this and this will give us the upper level conditions, showing a, let's see, here we go, it's off to the right, and I'm trying to drag the window and it's not going, so I'm going to use, okay, Firefox is just not responding at all, and now it is. I don't know what it's doing sometimes. Okay, there we go, 250 millibars. This is going to be up at about 35,000 feet. So it's showing these pennants on the flags. This is 50, 60, 70 mile an hour winds coming from the northwest. Good jet stream energy coming out of the central U.S. into Texas. And this also paints out a ridge over the Rocky Mountains here. So that extends up from New Mexico up to Wyoming and up to Montana. A couple of other good products to look at on here, and Firefox is not cooperating again. I have no idea what's going on. I'll try clicking on stuff, and yeah, here we go. I think it's just running laggy with Cam Studio here. 500 millibar vorticity. This looks pretty smoothed over to me, so it's not going to be very good at finding short waves, but this vorticity analysis shows us where there's curvature and shear in the upper level winds. When they cross the contours like this, this indicates where there may be some upper level energy acting on the atmosphere. So ahead of those patterns where they dip south like this, we're probably looking for some upper level lift. So we're probably seeing that here in Montana, Saskatchewan, and Alberta. As far as other conditions, let's see, which one of these would I recommend? 1,000 to 500 millibar thickness is a very helpful product. This is not so good in the summertime because there's not much movement of cold and warm air masses. But we do have an exceptional case today. We've got a Canadian high moving out of Alberta and Saskatchewan, and what we're seeing right here is packing of these red dashed lines. These are thickness lines. They correspond to how, I would call it probably an average of the temperatures in the lowest 18,000 feet of the atmosphere. So basically from the surface up to about 3 miles, if you kind of like take an average of the temperatures, that's kind of what this is. So this will help us find deep cold air masses, for example, which is what we have here to the north. So right there we've got probably a deep cold air mass over the Canadian prairie provinces, and this is showing the surface flow right here, these dashed black lines. So when they cross the thickness contours like that, we have what we call advection. Since they're coming from the north to the south, this is cold air advection. So we can say for sure we've got strong cold air advection coming out of Canada. When you have advection of temperature, that's one of the big things that produces weather, because if you have cold air and warm air just sitting there in its source regions, that doesn't do anything. When it's on the move, that produces temperature changes and upsets the balance in the atmosphere. So here, cold air spilling out of Canada, and even though we have tropical air coming out of the Gulf, you can see there's not much in the way of advection because the black streamlines are parallel to the thickness lines. So we're just basically moving more of the same product northward across the central U.S. Some other things to look at here. I'm going to reset the window here real quick. Okay, next product to look at is soundings. This is a plot of temperature versus height, basically directly from the weather balloon. So I'm going to make this a little more interesting and look at something way up in northern Canada. I'll pick the Canada chart here. Go up to Resolute and pull up their sounding. When you have the red line, this is the temperature. When it's way over to the left, that means we're looking at very cold conditions. And indeed, this temperature line, instead of being way over here, is off to the left. This indicates we've got a pretty deep cold air mass from the surface up to about 7,000 meters. Above that is the stratosphere. So the stratosphere is only about 7,000 meters up, and that's going to be about maybe 24,000 feet or so. So I guess if you're taking an airplane up to that part of the country, you're going to be cruising way up in this level, up at about 34,000 feet. You're going to be right in the middle of that stratosphere, and supposedly there's ozone and stuff like that, and I know there's some health concerns about exposure to ozone, but I guess if you're traveling on an airplane, you're not worried about that too much. A couple of interesting products here. And Firefox is... Okay, I've went to their mesoanalysis products page, and this gives us just some various upper level charts. I'm not going to go through all of these. I'm just going to pick a random one. Maybe on some other day we'll grab one of the others and talk about it. This time of year, probably water vapor is a good one to look at. This isn't really... There's probably a specialized product for this that is probably better, but... So we're just waiting on it to load some stuff here. Water vapor is a satellite-based product. And what this does is it doesn't actually sense moisture, but it senses heat from the ground that travels upward towards the satellite and is blocked by moisture. So if the radiation travels upward and it's extinguished by moisture, then we have less of that radiation reaching the satellite. It shows up as cool, which is what we see here. So there's a cool temperature reading. And that basically corresponds to where there's a lot of moisture. So here across the central U.S., the Rockies, we got the monsoon really cranking here. This is kind of like a plume of moisture going up to northern Nevada, Ohio, and not Ohio, that's Oregon, and Idaho. So a good moisture plume here, and out to the west here off into the Pacific region, the radiation has traveled directly upwards to the satellite, and it's made it without being cut off by moisture. So it's showing this very hot. We assign these hot temperature contrast. So as you can imagine, up in Canada, where there's cool conditions at the ground and it's traveling upward through moisture or not through moisture, either way it reaches the satellite cool. So it makes it a little harder to distinguish where there's moisture when you get into these cool patterns. And when it gets to be winter, then the water vapor product becomes very tricky to use. But during the summer patterns, very useful here. So there's another plume of moisture here going up through Georgia, the Carolinas, and into Tennessee and Kentucky. Okay, we'll go to the next few products, isentropic maps. We're not going to cover that right now. This is not very useful this time of year because everything's driven by convection. Cross-section analysis, that's probably not too useful either, so we're not going to worry about that. So we're gonna jump right into a few of their other products. Let me go back up to this weather analysis tools. Satellite and radar, that's another way of observing things that are going on right now. Let's see, hemispheric products. These are just basically different zoom levels. I'll take the 1 kilometer product. That's one of the finest grain composites that they have. I'm going to look at Montana. So we're zoomed in pretty tightly into Montana. Showing a lot of, this is visible here, this is showing a lot of, looks like mid-level and high-level cloud. But we can go down to the radar. See, click on radar, go to Montana. There we go, this is kind of a mosaic of different radars. Just basically showers and kind of drizzly, rainy weather. And then we can go to the actual NIXRAD sites. Those are actually the radars themselves. So I'm going to look at Oklahoma, not much going on, this is all ground clutter. I'm going to backtrack. Actually, I don't have to backtrack because they have a handy thing up here, say radar site map, so I can look at another radar. I'm going to go to Mississippi. This is Jackson, Mississippi, and we got a lot of showers and thunderstorms going on right there. They don't look very organized. There's probably moderate to weak winds aloft, so things are just kind of messy. And out north of there, it looks like this is more anvil or old thunderstorm activity, one of the two. And then the newer, stronger convective clusters are down here, where there's a lot more of a cellular appearance. And of course you can also run loops. I'm trying to drag Firefox and it's getting stuck, probably fighting with Cam Studio here. I don't know what's going on. Alright, there we go. I'm going to click on, there we go. Come on, you can do it. Okay, I'm going to click on this 6 here. See, these are loops. So we're going to animate 6 frames and kind of show you what's going on here. So this runs about maybe 10 to 20 minutes of radar data, and it shows us that we have a slow east-southeast movement on these cells. Alright, what else do we have to look at? Let me back this up here. Okay, I'll go down to Numerical Models. This is where we get into the actual forecasts. And it gives us a bunch of different models we can look at. There's the high resolution rapid refresh. This is the rapid refresh. It's a little less high resolution than the high resolution rapid refresh. We have the NAM, which is the basic fundamental US forecast model. We got a higher resolution version of that. And then we got a few others. Probably the most important ones that we like to look at are the GFS, which is the global forecast system. This goes out, I think, to 384 hours, so probably the last half of that period is not very useful because it's going to be pretty inaccurate. But so we click on GFS and it gives us a number of different products, and it looks like they've got some neat little services here. Looks like these guys are really on the ball with some of their stuff here. But I'm going to pick a random field. We're going to look at surface, maybe we'll look at temperature here, 2 meter temperature. So this is 6 feet off the ground. Gives us a few other fields like wind and temperature, that kind of thing. So basically showing that 0 hours forward in time from the 12Z model, which is 6 in the morning, and it's valid at the same time, 12Z Sunday, so this is 6 in the morning. It's showing that we got warm temperatures across Kansas and Oklahoma, and there's the push. I think I messed something up here. Let me go back here. Okay. So northern Canada right here, this is where we have that push of cold air coming in from the north. And this circular appearance to the isobars, this outlines where the high pressure area is. And if we go up to the top, we can animate the forecast period forward, go say 84 hours into the future. So this shows 84 hours in the future from the 12Z model, and it's valid on Thursday at 0Z. So that's going to be Wednesday at about 7 p.m. here. So showing very hot conditions down in the Rio Grande Valley of Texas. A big warm up there in Canada, but cool conditions across the Great Lakes, and there's high pressure here. So it looks pretty good there. Pretty good there in Ohio, Michigan. Less of the heat. So probably a warm front out in this area. And when we have a warm front this time of year in Missouri, Kansas, that's probably a good indicator that we've got rain going on. So probably a rainy pattern there in the central U.S. on Wednesday. As far as other products, I'm not going to really drag this on too much longer, but there's a few derived products. I guess you can click on precipitation and get an idea where the rain is. Let's see. We'll try this convective precipitation here. Alright, so that brings us to our last major section, the text products. Those are alphanumeric products from the Weather Service. And we got a few of them here, and got Firefox kind of locking up on me. Fighting with Cam Studio, I'm sure. So here we have severe weather text. This is going to be text products from the SPC Center. And it does have some graphical products too, so I guess this is kind of where it's just piling all of the National Weather Service public products. We've got state products here, so there's some very useful stuff here, like for Minnesota. If you scroll down to the individual offices, we have area forecast discussion. That's very helpful for understanding the forecast thinking at each office. So we have a short-term forecast here. They talk about thunderstorms in the forecast and how they're going to progress and what's causing them and all that. And you scroll down and you get a long-term forecast. Then we get into some of the actual hazards and centralized outlooks. HPC, that's the Hydrometeorological Prediction Center. They've got some products here. Long-term forecasts, climate forecasts, so on. Tropical Weather Center. Here we have the hurricane and tropical storm outlooks, and then we get into the flooding products. Then the very last section on their website is links. So if you just don't have enough there, you can follow those and pick up some other stuff to bookmark. So that's the College of DuPage website. I find that very valuable. If there's some other websites you would like me to cover in this series, and there's quite a few of them out there, just let me know and I'll be glad to do an overview and check out the weather, and we'll talk more about those. Anyway, if you like this series, please like, and if you haven't subscribed, please do so. Thanks, I appreciate you watching. Yeah, let's check out a few of these clips here in the sound library. See what they sound like here. Sounds very 80s there. It's like Miami Vice or something. Let's try number 3 here. Probably good for time lapse and stuff like that. A lot of these clips sound kind of dated. WTLA breaking news. I think we used that one for time lapse in Art of Storm Chasing. You know, the theme song is in here somewhere. I don't know which one it is, but it wasn't that one. Let's see, how about this one, track 22? Oh yeah, that's the Art of Storm Chasing right there. That's what we used for the closing credits. We actually did this video back in March of 1999 on an old Macintosh, using a iOmega capture device. I don't know how we did it, but it worked. Yeah, you see this is the computer where we put Art of Storm Chasing together. This was shot back in 1999, right around the time we did that. And that's Shannon Key right there that you see. Anyway, I appreciate you watching the series, and if you like it, please click like and subscribe, and hopefully we'll have more interesting stuff for you tomorrow.